Right, hello everybody, and welcome to the start of the mechanical part of the unit. And we're going to look at force, work and power. But first of all, we just need to understand what mass is, and you've probably heard people get a bit confused between weight and mass. In physics there is a difference. In mass it really is down to the number of atomic particles in a material, in a unit block of material. For example, this brick will contain many more neutrons, protons and electrons in it than, say, this block of similar sized block of polystyrene. You can see with this polystyrene I can quite easily pick it up with two fingers. Quite easy to do, whereas this brick isn't so easy. Despite the fact that I'm an accomplished athlete, I can't lift it up very easily with my two fingers. It's quite hard. So what's happening in this brick is that there are many more particles being pulled to the centre of the Earth by a force called gravitational force. And Isaac Newton first discovered a relationship between objects that fall to the ground and gravitational force, and he realised that if you threw a brick out of a window, it would accelerate at 9.8 meters per second. So within the first second, after 1 second, it would be travelling at 9.8 meters per second, and after the second it would be travelling at nearly 19 meters a second, and so on, faster and faster and faster. Now in reality, if you threw a brick out of an aeroplane, it would slow down to what we call terminal velocity, which is where it stops accelerating, because the wind resistance would slow it down, rather like when you jump out of an aeroplane with a parachute, without a parachute rather, you will eventually reach terminal velocity, but then if you pull the parachute you take full advantage of the wind, and that slows you down to a steady velocity. The polystyrene, however, because it's occupying a similar volume to the brick, it's offering a similar volume to the brick. It's not actually being pulled to the centre of the Earth very much, because it must have, in that same volume, it must have fewer atomic particles. And I'm not just talking about atoms here, we're talking about all particles that make up the atoms, because each particle is being pulled to the centre of the Earth, and the more particles you've got in a material, then the stronger that force. Now that force is defined as the Newton, and it's known as the Newton, which I forgot to write in there. So therefore 1 kilogram would have a force of 9.8 newtons pulling it towards the centre of the Earth. Okay, so that's what's happening there. Now, work. Well, what does work mean? Well, work means how much energy we use to move this object through a particular distance. So, for example, if I move this a metre up like this, I will have done some work in order to do that. It's a bit like when you go to the gym. You get your weights and you lift them up and down, up and down, up and down. You could actually lift them up and simply drop them. And sometimes you do see that in a gym. when people lift weights that are too much, it just drops down. But what's happening here is your muscles are doing some work in order to lift that up a certain distance and then put it back down again. So your muscles use exactly the same amount of energy to put it back down again as to lift it up. If I drop this brick onto the table, I don't want to damage the table, but if I drop the brick, all the energy that I'd stored up in that lift will be converted into heat. And you can actually demonstrate that. If I haven't got a Coke tin with me, but if I had a Coke tin and dropped that brick onto a Coke tin, all the energy that was stored in that brick will be converted into crushing that can. Same thing happens in a car. If a car is crashed into a wall at 70 miles an hour, all the energy that's stored in that moving car is converted into crushed metal, broken glass, and lots of dead bodies around, and all that energy is converted very quickly. The alternative is to press the brake pedal and gradually absorb all that energy to slow the car down. Right, so then we come on to work, which is what we're doing when we move this to a distance. So if this brick, say, weighed 1 kilogram and I moved it up 1 meter into the air, like that, and then dropped it down again, the work done would be 9.8 newtons. It should be force moving through a distance. I've made a mistake there. So that weighed a kilogram. Weighs a bit more actually, more like 2. If that weighed a kilogram, then by moving it through 1 meter, it weighs 9.81 newtons. There's someone at the door. It weighs 9.81 newtons, and if I move it through 1 meter, I've used 9.8 joules to do it. Now the other thing we've got to look at now is power, and that's the rate of doing work. So if I move this brick very, very slowly up to 1 meter, then that's what I call a low rate of doing work. If I was to lift this brick up very, very fast, like so, then I've done the same amount of work in a much shorter space of time. So the power is much greater if I lift the weight quickly than if I lift the weight slowly. I need the same amount of energy to move it to 1 meter, but the speed at which I do it, the rate at which I do the work, is known as power. And power is the rate of doing work, and that is what we call the watt. So in the next video I'll go through a couple of examples, and then you can have a go at some examples later which I'll put onto solar. Thanks very much.